Hey, welcome to the channel. We solve problems on this channel, but not limited to mathematics. All problems. Some problems are brought. We want to solve them today on mathematics. Actually, this it's an assignment, sort of. Call it holiday project. This particular question. It's on sector. Sector. You have to find the area of a segment of the circle. So you get the area of the sector, get the area of the segment. Alright, but as we normally do here, we will not solve the question. We'll solve a similar question. The student will now be able, with the understanding of what we have solved, able to solve his own problem. So we want to quickly have the background of the topic. Actually, this is dealing with plane shapes. Plane shapes have many shapes under it. You have circle, you have triangle, you have what they call it, rectangle, you have square. You have many shapes, but they are plane shapes. Now, let's take circle. When you have a circle, there's always a center of the circle. Don't mind my drawing. My drawing is not perfect. I intended to draw a perfect circle. Let's assume this is a perfect circle. There will be a center O. There are many things you can talk about circle. A circle, we have radius this way. A circle may have a diameter. A circle always have diameter. That's 2 radii. Diameter. Call it diameter. The line passing from circumference to circumference through the center of the circle is called diameter. This is radius. Now, this is called a segment. That's a segment. This space, that's the segment. This line is called a chord. A chord is a line from circumference to circumference, but not through the center of the circle. That's a chord. This is a segment. Let me draw another circle. This is center. This is a segment. This other part is also a segment. But this smaller one, we call it minor segment, and the bigger one is called major segment. Then this is radius R from the center O. From a circle, you can also have what we call sector. Sector, when you have a radius this way, another radius this way, this is called a sector. So these are the terms we need to know on this topic. Now let's talk about arc. Okay, before I leave this page, I'll tell you if this is A, point A, this is point B. You see, this line is called arc. The arc. The arc of the segment or the arc of the sector. That's an arc. That's the minor arc. This remaining part is also arc AB. Minor. This minor arc AB. This other one from this A to the other side back to B is also called arc, but it's a major arc. But all this is called a sector. A sector is different from a segment because a segment has no connection with the center of the circle, while a sector has a connection with the center of the circle. Okay, good. Now let's go on. Let's talk about the lengths of arcs. Now when you have a circle, you have probably, let's say you have a chord, this point A, point B. This arc AB. With the help of the radius being known, you can actually calculate the length of arc. The length of arc. Now let's talk about circumference. Circumference equals to, what's the formula for circumference of a circle? It's 2 pi r. Now what we have here is a fraction of the circumference. Everything from point A round about the circle back to point A is called circumference. This is the formula. But when we talk about arc, arc is a fraction of the circumference. But what's the fraction? Now we need to consider the angle of that sector. Now the angle round about this center of the circle is 360. Angle round about is 360. But angle just within this sector is theta. Not up to 360. But we may not know the value. And so most times the value will be given. Now let's talk about fraction of this circle. This angle round about the center of the circle. Everything is 360. Theta is just a fraction of the 360. Now also this arc is just a fraction of the whole circumference. So when you want to talk about length AB, length of arc AB, it will be the fraction. It's a fraction of the circumference. But what's the fraction? The fraction is angle over 360 times the whole circumference, 2 pi r. So this becomes the formula for the length of an arc. Let me still explain to you. The circumference of a circle is also theta over 360 times 2 pi r. Yes. But for a circle, the full circle has the full angle. So it will be 360 over 360 times 2 pi r. By the time you cut 360 here 1, 360 here 1, what you have is 2 pi r remaining. That is why the circumference of a circle is 2 pi r. Because you are talking about the full circumference. So you use the full angle. Now we are talking about, when we talk about arc, we are talking about a part of the circumference. So we are going to use a part of the angle. A fraction of the circumference. So we are using a fraction of the circle. So actually the length of arc is now the theta over 360 times the whole circumference, the fraction of the whole circumference. This is the fraction part, this is the whole circumference. So this is the formula. We normally keep every formula inside a box. Every formula should be inside the box. Then it should be inside the box upstairs also. You memorize it. No cramming. Some people successfully cram this and still pass. But it's not the best. It's not our method here. Our method here is to understand why this formula is this way, so that you can never forget. Now, let's look at an example. The length of an arc. Look at this one. An arc subtends an angle 105 degree at the center of radius of a circle of radius 6 cm. Find the length of the arc. Now, one thing you need to do to help yourself is to transform the question into the diagram. The arc, an arc subtends an angle of 105. An arc AB. This arc subtend an angle of 105. That means to the center of the circle, angle 105 degrees. You translate the question into a diagram. At the center O of radius 6, that is 6 cm, radius 6 cm. This is also radius 6 cm. They said find the length of the arc if pi is 22/7. Now, going by the formula, length AB, the arc, is angle given over 360 times 2 pi r. Now, let's go. Angle given. The angle given here is 105. 105 over 360 times 2. The pi is 22/7 as given. And the radius, 6. So you can actually calculate. Let us cut 6 here, 1. 6 in 36. 6. With this 0, you have 60. 2 can cut. 2 here. 2 here is 1. 2 here, 30. Now, can 3 cut 30? Can 3 cut any here? Yes. 3 in 105, is it possible? Let's check. 1 plus 0, 0. 0 plus 5, 6. Can 3 cut 6? Yes, so 3 can cut 105. So 3 here, 10. 3 in 10, 3. Remainder 1. 3 in 15, 5. We are moving forward. Can we cut again? Of course, yes. 7 here, 1. 7 here, 5. Okay, can we cut? Of course. 5 here, 1. 5 here, 2. Can we still cut? Of course, yet. Yes. 2 here, 1. 2 here, 11. So everything has turned to 1. 1 times 11 times 1 over 1 times 1. 1 times 1 times 11 times 1 is 11. 1 times 1 is 1. 11 over 1. So, length of the arc AB equals 11 cm. 11 cm. That is how it works. That's how to find the length of arc. Now, let's go to sector. Sector. I want to calculate sector. Now, this is length. Now, when we talk about length, it is one dimensional. You see, the length here is, the only length here is r. There's no other length. Now, let's talk about area of sector. When we talk about sector, we talk about area of sector. area. Now, when you talk about area, area is two-dimensional. Length times breadth. Length times length. Breadth times breadth. Radius times radius. It's two-dimensional. So let's talk about circle first. For a circle, area of a circle is what? Is 360 over 360 times pi r square, because it's two-dimensional. Radius times radius. So you have pi square. Now, when you cut this, because we are talking about full circle, it will be the total angle over 360. And the total angle is 360. When you cut, you have pi r square. Now, in the world generally, area of a circle is pi r square. This is where they got it from. But when we talk about some part of the circle, look at the picture now. A segment, like you have a cake, birthday cake, and you cut some parts out to eat. That is called a sector. From the center, you cut off some parts, it is called a sector. Now, look at a sector. It is a fractional part of the whole circle. So when you are talking about area of a sector, it's going to be the angle, part of the angle that forms this sector over 360 times area of the full angle area of the full circle by r square. That's how it works. So this is the area formula for area of a sector. Since sector is a fractional part, the area also will be a fractional part times the whole part. This area. When you talk about length of arc, you use a fractional part times the total arc, total full circumference. But when you talk about sector, area of sector is still fractional part times the area of the full circle. Don't forget. Now let's have an example. An example of area of a sector. We have a question here. Find the area of a sector which subtends an angle 80 degrees from the center of a circle of radius 12 cm. Now, what you need to do actually is you begin with the diagram. If you don't have the diagram, you are likely going to make a mistake. So, draw it. There's a circle and there's a sector. Now, you have 80 degrees for the sector. Radius is 12 cm. You have to find the area of this sector. Sector is like a part of cake. Sector, this sector. Now the formula, you have been given the formula. Area of a sector is fraction of the angle times this is area pi r square. Area as square. So that's the formula. Now for this particular question, area of that sector equals 80 over 360 times pi, that's 20 over 7, times r square, radius square, radius times radius. So 0 will cancel 0. Then 12 here 1, 12 here 3, 3 here 1, 3 here 4. So what we are left with is 8 times 22 times 4 all over 7. So let's get the answer. At this level, we can use a calculator. Using a calculator, you have 704 over 7, and that gives us 100.57 cm square. So you have 100.5 or 0.6 cm square. That is the area of the sector. This is how to go about area of a sector. Now where we are going, we are getting to where we are going gradually, and this is the final journey, area of segment. We went through area of sector so that we can use it to solve area of segment, because you have to get the sector before you get the segment. Now, like I told you, this is a segment. To get this area, you must get the sector. When you get the sector, you now subtract the triangle, then you get the area of the segment. So area of segment equals area of sector minus area of triangle. The segment is a part of the sector, and when you divide the sector into a segment, the other part is a triangle. So for you to get the segment, you subtract the triangle from the whole sector. That's why we went through sector. Now, you know how to get the area of a sector. Do you know how to get the area of a triangle? Area of a triangle can be 1/2, that's half base times height. It can also be 1/2 r square sine theta. There are some ways by which you can find the area of a triangle. It depends on what is available. If you have the base, you have the height, use it. If you don't have the base or the height, you use this. You use the angle. So let's have an example and let's solve it. This example says calculate the area of the shaded segment of the circle shown above. Look at the area shaded, that's the segment. Look at the whole thing is a circle, and there is a sector from OAB. You see, this is a sector. Now, the formula is area of segment equals area of sector minus area of a triangle. Now let's deal with the sector first. Area of sector, that's going to be theta over 360 times pi r square. Area of triangle, this triangle can be solved using the angle. Now you can use 1/2 r square sine theta. So what we need to do now is we kind of substitute. The theta here is what? 63 over 360 times 22/7 times r square. Radius, let's square the radius, that's 10 square. Then minus 1/2 times r square, that's 10 square, radius is 10. Then sine theta 63. Okay, you can do some punching of calculator here, or you cut. 7 in 7, 1. 7 in 63. You have 9. Okay. What can we cut here? Okay, let's spread out. We have 9 times 22 times 10 square is 100 over 360 minus 1 over 2 times 100 times sine 63. All right, ending zeros can cut. 9 here 1, 9 here 4, 2 here 2, 2 here 11, 2 here 1, 2 here 5. So you have 11 times 5 remaining here minus, let's call this one 2 here 1, 2 here 50. Now sine 63. Sine 63 is, okay, let's write this 50, 1 times 50 times sine 63 is 0.8910. Okay, let's multiply out now. 11 times 5, that's 55, minus 50 times 0.8910. You have 44.55. So when you subtract 44.55 from 55, you have 10.45. That's the area of the segment. 10.45. The unit is cm square, because that is area. So that is how to solve the area of a segment. That's simple, so simple. Don't go away. Now I want you to click subscribe button, please. Then click the notification bell, please, so that we can get other videos to you. And we can also always collect questions from you. Now we are back to the real assignment which brought the student to this channel. So the assignment is to calculate the area of the shaded segment. Now you have the radius, you have the angle. You know what to do. Just as we have done here, just substitute, bring out the formula. The formula is this. Let every formula be in a box. That's the formula. Then substitute for the parameters in the formula. Then you are going to get your answer. So if you look at this, it's almost the same as what we have set. They gave us the radius here, and we have radius here. The angle is given here, we have the angle here. So everything we have done here, you can do it and repeat everything here so that you can get your answer. Like we said, we solve problems. We don't solve assignment for the students. We just teach the student on how to solve the assignment. Alright, the question here is about sets. Sets involving Venn diagram. 100 members, this number 13. 100 members of a sports club plays at least one of the games: football, basketball, and volleyball. That is called 3 events. 3 events set. If 20 play football and basketball only, 15 play football and volleyball only, 26 play basketball and volleyball only, X play all the 3 games, 2X each play only 1 game. How many play basketball altogether? That's the question. But I will not read this question. I'll not give you fish. I'll teach you how to fish. I'll give you something that will help you to learn how to answer this question. Now there's another question here. There's another question here. That number 11. This one. I'm going to treat this. I'll use this to explain to you. Now, this is a Venn diagram. They call it Venn diagram. Venn diagram always have what we call the universal. This is the universal. Then you can have events inside. 1, 2, 3 events. Now in this case, this one is labeled, one of them is labeled F. This one labeled V, volleyball. This one maybe table tennis or so. Yes. I'm just going to use this diagram to explain everything. Now this is the universal. Everybody present in the competition or so. These people in this circle play football. These people play volleyball, while these people play table tennis. Alright. There are segments here. Each of these segments has its own contribution. Now, everything all add up to the universal set. So let's label. Watch. This is 1. That's a segment. This is 2. This is 3. This is 4. This is 5. This is 6. This is 7. Then this one is 8. 1. If you look at 1 belongs to football, volleyball, and table tennis. If you look at this section, this segment 1, you see, it's a part of football. Look at this football. 1 is there. It's a part of volleyball also. 1 is there. It's also a part of table tennis. Do you understand that? So 1 talks about people in those 3 events. That's the segment for 3 events. There are some people, they play only 2. Look at this. Football and table tennis, they have something in common. 2. This segment number 2 belongs to football and also to table tennis. Volleyball is not a part of it. It's not a part of volleyball. 3 is also a part of volleyball and table tennis. 4, segment 4, is a part of football and volleyball. 7 is a part of football only. 6, a part of volleyball only. Because if you look at 6, if you look at 7, the other events are not there. And also 5 is a part of table tennis only. So all the terms in mathematics are very, very important. Like you hear only. That only means something. So I'm going to do it again. I'm just using this to explain, but I'll do it now. Before I go, let me tell you that universal is equal to the sum of all the segments. Segment 1 plus segment 2 plus segment 3 plus segment 4 plus segment 5 plus segment 6 plus segment 7 plus segment 8 makes the universal. So, and whenever you have an equation, you can easily solve a problem. This one is the equation of set. For 3 events, this is what you have. 8 segments. Now, okay, I did not explain this 8. 8 are those people outside. They are not involved in any game. They don't play football, they don't play volleyball, they don't play table tennis. They are just outside. So there are categories of people like that. They are just outside all the events. But they are still within the universal. Maybe they were sick, they could not play. So eventually, they are enlisted in the competition but did not participate in any. So they are there. Everything will sum up and give you the universal set. Yeah, this is another example that I want to use for explanation. Yeah, look at the Venn diagram. I'm going to read the question. Then we look at the question and the solution together. In a group of 120 students, that's universal. 120 students. The universal is 120. He said 60 studied mathematics, 40 studied physics, 50 studied chemistry. All right. Let me tell you what they are trying to do here. Mathematics, physics, and chemistry. Now, 60 studied mathematics. This 60. The universal is 120. He said 40 studied physics. Then chemistry, 55 studied chemistry. Now, this whole circle of mathematics, everything found inside there is 60. But among the 60, some people are offering physics and chemistry. Some people are offering only physics. Some people are offering, math and physics. Some people are offering math and chemistry. All that we need to consider. Let's read the question. They said, and 22 studied none of the 3 subjects. None means they're outside. It's part of the equation. Then 12 study physics and mathematics. Physics, mathematics, in between them, 12. Then you have 8 studied chemistry and physics. Chemistry, physics, 8. Between chemistry and physics, you have 8. Then, okay, wait. 12 studied physics and mathematics only. Okay, that means you will not subtract this one. Just write only 12 only. Then 8 physics and chemistry only. The only is very important. I'll explain. 7 studied mathematics and chemistry only. Mathematics, chemistry only. 7. Now that's the whole explanation. You have to draw the Venn diagram illustrating the information. Good. Now they said this is only. When you hear only, there's no need for subtraction. So this is 12. This is 7. This is 8 because they mentioned only. Don't bother yourself any longer. Now there are people that will study the 3. They are here. You don't know them, but there are people there. You don't know the number, so you have to use a letter to represent the number. Make it X. You know why I wrote this 60 outside? Because the 60 belongs to the whole circle. But remember, from the 60, 12 has gone to participate in physics. 7, they are still in mathematics, but they also share with chemistry. Then X shared with physics and chemistry. Now what will remain here will be only. And when you say only, that means others have been subtracted. Now they said everything all together. They did not say, when they told us that 60 studied mathematics, they did not say only. So you have to subtract. This one, they said 12 only. You don't subtract. This one, they said 60, study mathematics. You have to subtract these three components that share with others. So you have 60 minus, open a bracket, 12 plus x plus 7. Because they said 60, they did not put only, so you have to do extra work. Only means stop there. Here they said 12. For this segment, said 12 only. That means you don't need to subtract. If they did not put only, you will have said minus x, because this is a big segment, but some of them came out. These one are just maths and physics. Since they write only, they said only, you don't need to subtract. If they did not put only, you have 12 minus x. But only means this is just the segment. They have done the subtraction. This one is 60. They did not do the subtraction. So you have to subtract other people in that family of maths. That's why you put minus all these added together. Now 40, they did not say 40 study physics only. They said 40 study physics. They did not put only. You have to do extra work. You have to subtract the other components in that family of physics. 12, x, and 8 have to be subtracted. So this is 40 minus sum of 12, x, and 8. Do you understand? Now, for the chemistry world, they said 55. Since they did not put only, it will be 55 for you to get the remaining segments. It will be 55 minus others that are shared with others. 7, x, 8. So it's going to be 55 minus all others that have shared with others. So 7 plus x plus 8. Now you have all the components. You have all the components labeled. So what you are going to do, you use the equation. Look at the equation. Universal equals to x plus 7 plus 8 plus 12, then plus, now 60, the first part is 60. Let's break it down to make it easy for ourselves. This will be 60 minus 12 plus 7, 19. 19 plus x. When you open this bracket, you have 60 minus 19, then minus times plus minus x. So that's what you are going to write. 60 minus 19 minus x. That's this. Now for this one, let's break it down. 40, 12 and 8 can be added together. That's 20. 12 plus 8 is 20 plus x. So when you open bracket, it will be 40 minus 20 minus x. So plus 40 minus 20 minus x. Then the last segment will be 55 minus 7 plus 8, 15 plus x. Open bracket, you have 55 minus 15 minus x. So that's the second to the last segment. You have plus 55 minus 15 minus x. Don't ever forget the ones that did not participate in anything. So that will be plus 22. This is an equation. Our universal is what? Our universal is 120. So rewrite the equation. 120 equal to x. 7 plus 8, 15 plus 15. Okay, plus 12 plus 60 minus 19 minus x plus 40 minus 20 minus x plus 55 minus 15 minus x plus 22. It's getting tiny, but will expand. Where is that? Okay, 16. I don't add 16 instead of 60. Thank you. All right. We are just, this is now like algebra. You are just simplifying equations. There's no big deal in that at all. So this 120. Let's collect the like terms. X minus x. Wait. X plus x will cancel minus x. This is another minus x. Minus x. Okay. So we have, let's add all the numbers together first. 15 plus 12. That's 27. 27 plus 60. 87. 87. We can go slowly. Let me change this to 87. So we are done with all this. Now we have minus 19 and minus 20. Okay, there are some that are minus, there are some that are plus. Let's deal with the plus first. Plus 60. We have done that. 40 is plus. 40 plus 55 will give you what? 95. Then the last positive number is 22. 95 plus 22 will give you 117. Am I right? 117. So plus 117. Now let's deal with the negative numbers. Minus 19, minus 20, minus 15. Then let's deal with the letters. We have minus x, minus x. That's all. So 87 plus 117. What do we have there? 87 plus 117. We have 14 there. Carry 1. 1 plus this, 2 plus 8, 10. Carry 1 again. Add that one here. You have 204. Minus 19, minus 20, minus 15. Let's add them together. What do we have? You have this 39, minus 39, and 15. When you add them together, you have 4 there. You have 5 there. 54, minus 54. Then minus x, minus 2x. The equation is getting simpler and simpler. Now you have, if you subtract this, you have 150 minus 2x. That's 120 on this side. So bring, you know one thing that we know in mathematics is when you collect like terms, this 150, 120 will come to this side and become minus 120, because this is invisible plus 120, and crossing this magic bridge, you have it change, transform to minus. So this is minus 2x. It will have to go to the other side, crossing the magic bridge. It will now change to plus 2x, and the plus can be invisible. So you have 2x on that side. 150 minus 120 will give you what? It's giving you 30. So divide both sides by 2. X. When divide both sides by 2, you have 30 over 2 on this side. That's 15. So your x is 15. You get that? Now let's look at the textbook. They did not follow this pattern, but they still have 15. X equals to 15. The textbook may confuse you because of the nomenclature, but we have simplified everything here. So now you know x. Now you know X, you can redraw your Venn diagram. Let me just sketch. Now wherever you see X, you replace it with 15. That middle is 15. This is 12. This is 7. This is 8. And this one, 60 minus 19 minus X. Now 60, X is 15. 60 minus 15, that's 45. 45 minus 19. Okay, let me use this as rough sheet. 45 minus 19. What do you have? You have 15 minus 9, 6. 3 minus that, you have 2. Now you have 26. Now this is 26. Now this is 40 minus X. And that'll be, okay, 40 minus 20 will give you 20. Then 20 minus 15 will give you 5. So this is 5. This is 55 minus 15. 55 minus 15 is what? That's 40. Then 40 minus another 15, because our X is 15. 40 minus 15, we have 25. Am I right? You have 22. Now, this is the real Venn diagram. This mathematics, physics, chemistry. Now, with this, you can answer. This is the real Venn diagram. 5 here, 25 there. Mathematics, physics, chemistry. This is the real Venn diagram. With this, you can answer other questions. The other question said, draw the Venn diagram. Okay, we have done that. The next one is, find the number of students that studied all the 3 subjects. That's 15. All the 3 subjects at the middle. That's 15. We got X to be 15. So, that's 15. The third question is, find the number of students that studied only mathematics. And that's 26. Only mathematics. This only. So this is how to solve problems like this. Now, going back to our question, original question, let me just guide you a little more before I leave you to eat. 110 members of a sport club play at least 3 of the games: football, basketball, and volleyball. So there are 3 events. Draw 3 events. Diagram. Now the universal is 110. Sorry, 110. Then they said 20 play football and basketball only. Okay, with this, the games. Let's see the games: football, basketball, and volleyball. Now 20 play football and basketball only. Football, basketball only. 20 only means don't subtract. You are done. And said, 15 play football and volleyball only. Fix it yourself. 15 play football and volleyball only. You know where that falls? Football, volleyball only. You know where that will be. I should not solve your problem for you. It's your problem. So you solve it, then you become a champion. That's it. That's how we learn. Now, I said 15 play football and volleyball only. Football and volleyball only, 15. Then 26 play basketball and volleyball only. Basketball, volleyball only. Only. No subtraction. Then here you have X. Play all the 3 games. Where's the segment for the 3 events? You know it. You put X there. Then it said 2X. Play only 1 game. 2X each. That means the people that play football only, they are 2X. 1 game. Or basketball only, that's 2x, one game. Then volleyball only, 2x, one game. Now they said, do we have anybody that did not play any game? I think there's nobody who did not play any game. So let me give you this one. This one is 0. You have to fix all this from the question you have read. You fix all this, then you go to your equation. Universal equals, add all the 8 segments together, then make x the subject of the formula. Then you find out, they said how many play basketball all together. That means everybody in the circle of basketball will be added together. Not only basketball, not basketball only, but all together, all together. Even though they play other games, how many people participated in basketball? And that is the solution to that problem. Thank you. Please leave your answer in the comments. We might be giving awards to the winner. Thank you. God bless you. Remember to click subscribe button and the bell button. God bless you.